following story represents the reality of a company that produces gas compressors. A gas compressor is a mechanical device that increases the pressure of a gas by reducing its volume. It plays a crucial role in various industries like oil and gas, chemical industry, and power generation. Gas compressors are made mainly from steel, roughly from 70% to 90%, depending on the type of compressor. The company mainly imports its steel from 4 suppliers, one in China, one in India, one in Turkey, and one in Germany. Also, the company has 4 production sites that you can see here in yellow. The company also has 2 central DCs, one in Paris and the other one in Budapest. And the company has around 20 local distribution centers in these little purple diamonds along EMEA, and with that supply chain can serve around 200 customers distributed among the region. The board members need to define the strategy planning of the company for 2024 and 2025, and they are aware that CBAM will play an important role in their decision making. As their product is mainly made by steel, it means that from 2024, they will need to declare the embedded emissions in its imports, and from 2026, surrender the corresponding number of CBAM certificates each year. This means that their suppliers' steel variable cost will change depending on how carbon intensive their products are. Suppliers with low carbon intensity can represent an opportunity to reduce the total cost of the network. They need to evaluate the impact of CBAM in the supply chain and how the network should adapt to CBAM to remain competitive. And for that, they're trying to answer the following questions. First, how does CBAM affect their sourcing strategy? From which suppliers is it more convenient to import steel for the upcoming years? Second, if the sourcing strategy change, how does this impact their production footprint? Should the company think of readjusting their production volumes between their production sites? Third, if there is a new sourcing and production strategy, how does the distribution network needs to adapt to minimize the transportation and distribution costs? They know that evaluating the sourcing strategy is just the tip of the iceberg, as a change in the supply's variable cost can propagate to the full network. To support their answers with data, the company decided to use SC Navigator. IM's SC Navigator is an application that you can use to model your supply chain network at a strategic and tactical levels, and then run various scenarios against it to try and understand how to deal with an uncertain future. The company started by modeling their supply chain and bringing that in as a reference case. You can see that there are flows from their suppliers in China, in India, and they're all going to the production sites. And what we want to do now is to start considering CBAM in the optimization and see if things change and what are the things that are changing. In order to do that, we're going to go to the control panel. In the control panel, you can relax certain constraints and adjust your optimization options. In our case, what we want to do is to include in the objective the embedded CO2 emissions, so that are taken into consideration. And also, we can change values of parameters. For this case, for each ton of embedded CO2 emissions that I'm importing, I'm incurring in a cost of 82 euros because that's the price of the certificate. Now that I have changed the things in the control panel, I'm gonna press the optimize button. So with this new set of conditions, the software can tell me what is the optimal network design after making these adjustments. Now let's check at the new solution. We go to results again, and we can already see that the flow of goods is different. We see that after considering CBAM, for example, India is supplying only one factory instead of many, and China is not even supplying steel anymore. Remember that this shift doesn't have anything to do with the country of origin, but to the carbon intensity of each particular supplier. To get these values, we assume a random variability for the carbon intensity of the suppliers. In order to understand fully what are the difference between both solutions, we can go ahead to different reports that SC Navigator offers in order to understand those differences. You have got the ability to compare the two scenarios in the interface so you can see side by side what are the different costs and values of all the attributes in the solution. For that, I'm gonna first save these results into the database. And now I'm gonna select both scenarios and compare them side by side. I will load them. So in the right-hand side, I have the optimization without considering CBAM, and in the left side, I have the optimization considering CBAM. Now, let's head to the supplier report to understand what you're going to source and from where. In this graph, I can see how the supply was in both of the scenarios for each of my suppliers. So these two bars represents Duisburg, and we can see that without considering CBAM, it was not even optimum to supply anything from this supplier. But now that CBAM is applied, we can see that it's an important supplier in the network. The opposite for China. We were importing a lot of steel from China without considering CBAM. But if I consider CBAM, SC Navigators advise me to stop supplying for that supplier. In Istanbul, we can see that the volume diminished a lot, and India got a lot more supplier in favor. So apparently, comparing the cost of supply with the cost of CBAM, Duisburg and India are more competitive comparing to Istanbul and China. Then, if I go to the production report, I can see how this change in the suppliers affects my production volumes. The graph is similar, and we can see if we click on a production site like, for example, the one in Germany, that without CBAM, the volumes were lower than if I consider CBAM. For another one like the one in Italy, Palazzo, it's the opposite. This is because as this production site is closer to Duisburg, the new strategic supplier, the transportation costs are lower, and therefore it's more optimal to produce in this factory than this one. Then, if I go to the warehouse report, I can see how is the impact and what are the difference between both scenarios in my distribution network. Of course, everything that we see on the maps, if we scroll down, then we have tables down below with the detailed information. But the color coding here helps us to understand what are the main changes and what should we consider doing. We can then head to the cost to serve report in order to understand how does this change in the network impacts the cost to serve each of my customers. So for example, I can click on the map any customer. I will click Valencia, for example, and already have my updated information breakdown by product and by cost type for both scenarios. So if I select a product with the filters, let's say reciprocating compressors, I can see how was my cost without CBAM and with CBAM. And if I hover over, I can see how that cost is composed. Also, if I click in any part of the graph and I go below, I'm gonna see highlighted the information I'm clicking on, so I can understand fully which costs are driving my total costs. If I want to see an overall picture of my cost, I can also head to the KPI overview. Here I can clearly see for each type of cost, what are my differences between both scenarios so I can present to internal and external stakeholders in order to understand what do we need to do to adjust to these changing conditions. And that's how you run scenarios using SC Navigator and understand the difference between them.